Okay, consider the family of functions, this thing, where k is a constant. All right, find the value of k such that the slope of the tangent line to f at x equals 0 is 6. Slope of the tangent line is a derivative. So here is your function. I'm going to rewrite this as x squared minus 2x plus k to the negative 1, which I only do if the numerator is a constant. And then the derivative is negative yada, yada, yada to the negative 2. And then a chain on the inside, which is negative 2x minus 2. I'm going to go to the next page. And they're saying that the derivative at 0 is 6. All right, so I'm going to plug in a 0. So it's negative 0 squared minus 2 times 0 plus k. Remember, k is not 0, only x is 0. 2 times 0 minus 2. Okay, that's the right amount of parentheses. Okay, this is, there we go, this 0, that 0, that 0. So we get negative 2. And then k to the negative 2, those parentheses are not necessary, and they're saying that the slope at 0 is 6. So we're just solving for k here. So 6 equals 2k to the negative 2. Divide both sides by 2. You can I guess the easiest thing to do is write it like that, cross multiply, and you wind up getting k is radical 1/3. Or let's just keep it simple at 1 over rad 3. You could write rad 3 over 3. Nobody's going to get upset at that. The question is asking what is k, and that is it. Part B. Part B. For k equals negative 8, find the integral. So our function now becomes this one function, x squared minus 2x plus 8. Oh, no, minus 8. Minus 8. All right. And what we're doing is trying to integrate that as x goes from 0 to 1. Okay. This is part of the integration techniques where we factor it. And when we factor that guy, we get x minus 4, x plus 2. This is a partial fraction decomposition problem because this is not able to be integrated the way that this is. So both of those are linear factors. And therefore this, we can just say a is going to be the linear, is going to be the constant over the first linear factor. B is the constant over the second linear factor. X minus 4, x plus 2. We multiply everything by the lowest common denominator, which is x minus 4, x plus 2. We get ax plus 2 plus bx minus 4 equals 1. And we use this to set up a system of equations for a and b. So we get that ax plus 2a plus bx minus 4b is 1. Okay. Your constant of 1 has to be equal to those constants. So 2a minus 4b is 1. And then our non-constant terms, right, our variable terms, has to equal 0. So ax plus bx has to be 0x. And this is a system of equations that we can solve very easily just by multiplying this bottom one by 4. So this is going to give us 6a equals 1, which means a is 1/6. And if we look back at the orange before I changed it to have 4s in front of it, a plus b is 0, which means that a and b are opposite, which means that a is a 6 and b is negative 1/6. We're not even close to done, right? So what we're going to do is rewrite this integral using these instead of what was given. So your integral from 0 to 1 becomes a over x minus 4 plus b, actually let's do, let's see, over, what is the other one, x plus 2, right, the integral of that dx from 0 to 1, okay. These are constants, so we can factor these out, right? So what that's going to give us is 1/6 times the integral from 0 to 1 of 1 over x minus 4 minus 1/6 times the integral of 1 over x plus 2. And these are both ln situations, right? The derivative of the bottom is on top. So it's 1/6 ln, absolute value is important. And over here you have 1/6 ln, absolute value is important. And I'm not going to write the plus c because we're going to evaluate that. It's a definite integral, so we don't need to write down the plus c's. Now you don't have to do this, but I'm going to do this because it's easy. Because both of them have a 1/6, we can factor that outside. And also, if you have the ln of a difference, that is the same thing as the ln of a quotient. Oh, absolute values are important. Okay. And we're going to evaluate this at 1 and then evaluate it at 0 and then subtract them, and that will be our answer. So 1/6. So this is ln of the absolute value of 1 minus 4 over 1 minus 4. I'll write it out. 1 minus 4 over 1 plus 2. And then minus ln of 0 minus 4 over 0 plus 2, plugging in the 1 and the 0. So this becomes ln of the absolute value, let's see, negative 3 over positive 3, but absolute value is positive 1. And negative 4 over positive 2 is negative 2, but absolute value is 2. Ln of 1 is 0. The power I raise e2 to get 1 is 0. So we wind up just getting negative 1/6 ln of 2, and that is good enough to be your final answer. Part C, same question, sort of, but they're asking for k is 1. So it's a completely different integral, x squared minus 2x plus 1 dx, and they want to know if that diverges. Now the fact that they're saying, does this integral diverge, not a series, but does this integral diverge, that they're giving you a hint that that this is probably an improper integral, meaning there's some drama with it, okay? Now, in this one, the trick of integrating is recognizing that that denominator is a perfect square. And if it's a perfect square, it can be written like this. This is able to be integrated, right? So it's x minus 1 to the power of negative 1 over negative 1 as we go from 0 to 2, which is negative 1 over x minus 1 as we go from 0 to 2. Now, this doesn't look like too much of a problem, except for one thing. They're giving you a hint. They're saying, or show it diverges. It might diverge. Now, if you plug in a 2, you get 1 over 1. That's not a problem. And even if you plug in a 0, you get 1 over negative 1. That's not a problem. But the trick here is recognizing that this is undefined at 1. And therefore, inside here, inside that interval, is an issue. And this involves the limits. You should look at the answer key to see the actual way that one should really write it. It has to do with limit from the left and limit from the right. I'm not even going to write that right now. I don't know, how much would the AP take off? I don't know, maybe nothing if I were lucky. But this is an improper integral. And there's a break at 1, and it winds up not working, and therefore it's going to diverge. But look back at the actual AP guidelines for how they're rating to see the actual notation of what it is you should be writing down.